Have you ever just looked up at the night sky and thought the whole thing seemed, well, a little too perfect, almost a little too stable to be an accident? Well, we are about to dive into a theory that says you're right. A theory that sees our universe not as some grand, unsolvable mystery, but as a giant, functioning machine.
So, to get why anyone would even think of such a wild idea, you have to start with this number 95%. Yeah, according to our best science right now, that's how much of our universe we just can't explain. We've given it these placeholder names, right? Dark matter and dark energy, which, let's be totally honest, is just a very fancy way of saying we have absolutely no clue.
And it's right in the middle of that giant question mark that a chemical engineer named Daniel Correa steps in. Now, he's not looking at this 95% problem like a physicist. He is looking at it like an engineer. And from that point of view, he asks this really powerful question. What if all this mind-bending complexity we see in the cosmos is actually just the simplicity of a huge engineering process at work? All right, let's get into it. First, we're going to lay out that standard 95% problem. Then, we'll unpack Correa's really elegant solution, something he calls the cosmic refinery model. From there, we'll see how this completely redefines dark matter and dark energy, and then wrap up with how it paints a picture of a universe that is literally engineered for stability.
Okay, so first things first, let's just do a quick run through of the official story. Right now, for the math to work on everything, from how galaxies spin to why the universe is expanding, our standard model of physics has to include two completely mysterious things that we've never, ever detected.
And wow, this chart really puts it all into perspective, doesn't it? Everything we actually know, everything we can see and touch and measure, every star, every planet, you, me, all of it is in that teeny, tiny 5% sliver. The other 95% is split between some kind of invisible, dark matter that's supposedly holding everything together, and this even more baffling dark energy that's pushing everything apart. It's a huge mystery. So Correa's theory starts by doing something pretty bold. It just throws out the foundational idea that our universe is this closed, isolated box. Instead, he says, no, what if it's an open system? Think of it like a single piece of equipment, a reactor maybe, that's just one part of a much, much bigger factory, a multiverse. And what's so cool about this is how the theory basically translates a boring old engineering diagram, like you see on the left, into this incredible cosmic vision on the right. It completely reframes our universe as this dynamic, flowing system, with pipes coming in, processes happening inside, and pipes going out. In this system, it has three main stages. So, the Big Bang, that's not some explosion from nothing. It's just an intake valve opening up, injecting super compressed stuff from the multiverse. Then you've got the stars. They're basically little reactors, cooking that raw material into heavier elements. And black holes? They're not cosmic vacuum cleaners after all. They are the system's suction pumps, recompressing all that processed material and sending it back out to the multiverse. Okay, so how does this industrial model actually solve anything? Well, let's start with that first big mystery, dark matter. See, physicists had to invent it to explain why galaxies are spinning so incredibly fast that, based on the gravity we can see, they should have just flown apart billions of years ago. And here is the key shift in thinking. Instead of some invisible mass inside the galaxy adding extra gravity, Correa says it's an external force pulling on it. So the universe isn't holding the galaxy together from the inside. The flow of the entire system is pulling on it from the outside, creating this kind of cosmic tension or drag. And this just brilliantly illustrates one of the theory's key predictions. It reimagines galaxies not as these fixed, static things, but as temporary whirlpools in a giant cosmic river. The external suction is constantly, slowly unwinding them, stretching their arms out. And the wildest part? We actually see this happening. We just call them stellar streams. All right, now for the other 68% of the cosmic puzzle, dark energy. This was dreamed up to try and explain one of the weirdest observations in all of science, the fact that the expansion of the universe isn't slowing down, but is somehow accelerating. And again, the theory just flips the whole thing on its head. It's not some mysterious push from the inside, but a totally logical pull from the outside. Just think about water going down a drain. The closer it gets to the drain, the faster it moves, right? Well, Correa says that acceleration we see is just matter speeding up as it gets closer to the universe's exit nozzles, the black holes. This image here helps you visualize it perfectly. The universe isn't being inflated like a balloon by some spooky energy. No, it's a dynamic flow. It's a balanced process where all the matter is being pulled towards these recompression sinks, and that pull creates the effect that we measure as accelerated expansion. But look, any good theory has to be able to stand up to some tough questions, and a physicist's first question would be, okay, but what about gravitational lensing? I mean, that's the effect where light literally bends around massive objects, and it's considered our best evidence that dark matter is real. So how does an engineering model explain that? The answer comes straight out of fluid dynamics. We all know light bends when it goes through things with different densities or pressures, like when you put a straw in a glass of water. Correa argues that what we're seeing isn't a mass lens, it's a pressure lens. The mechanical stress on the very fabric of spacetime, caused by all this suction and flow, is what's actually bending the light. Maybe the most beautiful, most elegant part of this whole theory is how it explains our universe's incredible stability over billions of years. It suggests that this isn't some happy cosmic accident, but that it's actually a feature of its design. So just like a boiler in a factory has a safety valve to keep from exploding, the universe has a feedback control loop. It's always monitoring its own internal pressure. If those black hole pumps start sucking out a little too much material and the pressure drops too low, the whole system triggers a new Big Bang pulse. It just opens the intake valve to repressurize itself and keep it from collapsing. It's a self-correcting machine. So what you're left with at the end of the day is this really stunning application of Occam's razor. I mean, instead of inventing two mysterious new forms of stuff and an impossible explosion out of nothing, this one theory unifies all three of those great mysteries into the interconnected parts of a single understandable process: injection, flow, and suction. And this brings us to the final, really provocative thought, something Correa calls his checkmate question. Think about it. If dark matter is a real particle with mass that's affected by gravity, then our black holes should have been gobbling it up for billions and billions of years, right? They should be trillions of times heavier than we see them. The fact that they aren't is a huge problem for the standard model, but it makes perfect sense in a universe where dark matter isn't a thing you can eat, but just a tension effect. And it really leaves you wondering, are we living inside some grand cosmic mystery, or are we just living inside a brilliant machine?